Morning.
Circle. When we're totally done with this, for some reason people lose sight of why we even talked about it. The reason we're doing everything on these 2 pages of notes is because we're trying to prove that things are exactly the same. In this case, it's triangles being exactly the same. Up until this point, we've just been kind of looking at sides, angles separately. Now we're going to take a look at entire figures. How many angles are in a triangle?
33.
How many sides are in a triangle? What is 3 plus 3? 6. If you have 6 pieces of a triangle equal to 6 pieces of a triangle, does it seem as if they should both be the same triangle?
Yes.
Yeah. 6 pieces are exactly the same, 6 pieces are exactly the same. We never have all 6 pieces being congruent to all 6 pieces. But if we have 3 or sometimes 2, that's enough to say that we have congruent triangles. And that's what this first one is saying. Write down SSS congruent to SSS. What do you suppose S stands for? Side. This is the official version or justification. You don't have to write all that. You're just going to write SSS. But realize that we're saying that 3 sides are congruent to 3 sides. We're assuming that you understand that you're dealing with 2 triangles at once. These are very straightforward. We're handing you all of this information. That's not always going to be the case. Circle one of these. When you're trying to decide which postulate or theorem to use, look at one triangle and then look at the components that you actually know. We know slash mark, slash mark, slash mark. What do slash marks go with, sides or angles? So this is a side and a side and a side congruent to another side, side, side. Put it over here. When you see the word by, that's really asking for a justification. Then let's put an arrow from here to this symbol. What's that symbol? Congruent. That's the whole point of this. Because we know 3 items, not 6, but just 3, that's enough to say that the 2 triangles are congruent. Then we're going to write a congruence statement. You can't just throw down any letters in any order. The first one, we can. We can write down ABC, CBA, BCA. The second one, we have to make sure that it corresponds to the first one. What corresponds to letter A in the second triangle? D. We got D. What corresponds to the B? F. And then C goes with E. So it's not necessarily in alphabetical order. You have to make sure that things correspond. The first ordering is up to you. The second one has to correspond. There are 5 different ways of proving that triangles are congruent. They're already up on the sideboard. Notice what's next to those 5. What 2 words? Some are more obvious than others. You don't have to write down that SSS is a postulate. We can put it here if we want to. But I'm not going to require that on tests, quizzes, or when you're doing a proof. You might see it show up on an SOL or a standardized test, but I'm not really caring whether or not you write down postulate or theorem. But somewhere in the back of your mind, think to yourself that that's fairly obvious. If I hand Brandon these 3, make a triangle out of that. Jeremy, make a triangle out of this. Quickly. Wake up.
Jeremy, hurry up.
Hurry up.
Hurry up.
Hurry up.
There. I gave him another orange one. I gave him another blue one and another purple one. Snap them together for me. Does it seem pretty obvious that if I gave them each the same length, they should come up with the same triangle?
No.
Yes.
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 Well, they,
Because one.
We get the same triangle?
yes.
Yes.
Yes. Did I tell them anything about the angles?
No.
No, but they still came up with the same triangle. That's what we're saying here. I don't have to tell them anything about the other three pieces of the triangle. These three ideas are enough to say that you've got two equal triangles. For the second one, we have side angle side congruent to side angle side. What does that look like? That looks like this. I've got my yellow and blue pieces here. They're all the same length. If I make a 45-degree angle with that and then match it up with a 45-degree angle there, does it make sense that the third side would have to be the same from here to here and from here to here? So that's pretty obvious also. So that's probably a postulate in sections 4.2 to 4.6 in your book. Circle this one and actually label it in the drawing. We have a slash mark. Well, that's a side. We have an arc. That's an angle. A couple more slash marks. Side. Write down side angle side. Where is the angle position-wise in comparison with the two sides? In the middle, in between. We don't use those terms. We use this term. It's called included. The included angle just means that it's in between. You can only use SAS if that angle is directly in between and if it's formed by the two sides that you're interested in, the ones that have the slash marks or the congruent pairing. Triangle POE, if I use that ordering for the first one, what should be the ordering for the second one? WRL. Pay attention to slash marks. Pay attention to how many arcs are on angles, and that will give you the evidence and information you need to make your congruent statement. Angle side angle. This time we have two angles, and we don't say in between. What kind of side is this? Included side. ASA. And if you look at the actual drawing, you have an angle, a side, and then another angle. Is the side directly in between?
Yes.
Is it connecting the two angles?
Yes.
Then we can actually use that as our justification, which tells us that we truly have triangles that are identical. And if I put in MAY, what would be my congruence corresponding statement? UTG. Turn your paper over. At the very top of page 2, we don't want to forget things we've learned before, so write down vertical angles. In the middle, let's write common side. And on the right, we'll write alternate interior angles. Before you make a decision on which of the 5 postulates or theorems prove the triangle is congruent, see if you've got these things, because that's the only way you can put more information into a drawing. You can't look at a drawing and say it looks like it's the same. None of this is drawn to scale. So when I look at number 1, I'm asking myself, do I see any vertical angles? No. Do I see any common sides like I do in number 3?
Yes.
No. Is it right next to each other?
No.
No. So I don't have that. Do I have anything that's even remotely parallel? Because that's what I need if I want alternate interior angles parallel. I don't have that. So I'm just going to go by the information I have in here. Label what you've got. What's the slash mark? Side or an angle? How about the box? AS. Is the angle directly in between?
Yes.
That means I can use SAS. What does that prove? That proves that the two triangles are identical. So I can write congruent. Now I write my statement. I have ABC. Congruent to what? What goes with A? FED. So one's the congruent statement with corresponding pieces. The other one is the justification. They're worth equal amounts on a test or a quiz. If you just write down this, you're going to get half credit. If you write down your statement without a reason, you're only going to get half credit. Make sure you read directions and give me the answers that I need. For number 2, does number 2 have any vertical angles?
Yes.
Put it in. You're allowed to put in things that you have justifications for. Do we have parallel lines? Yeah, I see little arrows here and here. So that means I can put in arcs here. Do I have a Z shape in there? Do I have a backward Z shape?
Yes.
So I could put angles here and here. There isn't a postulate or theorem that's AAA in this chapter. There's one later on and it helps us do something else. But we don't have that as a choice in this chapter. You got a little more information up here. Do exactly what I just did. Underline bisect and circle what follows it. Last year, the mistakes we saw were that people bisected everything. The only thing that's getting bisected is RP. So the only thing that gets a slash mark are the two pieces of RP. GA, we don't do anything with. It's doing the cutting. It's not being cut. So now I want to focus on one triangle and see if I have enough information. What's P? Is that an angle or a solid? It's an angle. What's the slash mark? Side. What's the vertical? It's an angle. I've got ASA. I had more information, but I didn't really need it. ASA was enough. That means that the two triangles are identical. Triangle R. A. What's in the middle there? O. What goes with R?
A. No, P.
P. What goes with A?
G.
G. And O corresponds to itself. It's in both triangles. Question 3. You go through those 3 ideas first. Do I have vertical angles? No. Do I have a common side?
Yes.
Mark it. That's like this. That's like having the 2 blue pieces like that. Well, could I separate the 2 triangles and you still have blue equal to blue?
Yes.
Yeah. Well, we're just not going to separate them. We're going to keep it right here. We're just going to mark it. Is it equal to itself? What property is that? When you look in a mirror, do you expect to see yourself? Reflexive. Write down reflexive properties. So you can be thinking in your mind common side. You can be thinking it's equal to itself, but in a proof, we are going to actually write reflexive property as our reason, as our justification. Is 2 equal to 2?
Yes.
Well, put a slash mark in there. Is 3 equal to 3?
Yes.
If you then focus on just one triangle, what components do you have?
SSS.
SSS. The only thing you have are slash marks. You don't know anything about the angles. What does that tell me? That tells me that the entire situation is congruent. And LMO is congruent to NMO. M and O correspond to each other. They're in both triangles. Nothing was parallel. I didn't have to worry about alternate interior angles. Nothing's parallel here. There aren't any vertical angles here. Is there a common side? Mark it. Put a slash mark right in the middle. If it helps you to redraw things, some people like to actually separate the two drawings into R, S, and T, and then have U, S, and T, and then show that ST is equal to itself. That's up to you. If you like to view things that way. Is 120 equal to 120?
Yes.
But this time, that's an arc. Those are angles. 21 is equal to 21. Focus on one triangle. What do you got?
Angle, side angle.
Angle, side, angle. Focus on one triangle. Label. Is the side truly in between? Is it an included side? Yes, it's connecting the two angles. It's included. Now I can say UST corresponds to RST. Do we have a common side in number 5?
Yes.
Mark it. Put a different amount on there because we've already got something that has one slash mark. Focus on one. I see an S, I see an S, I see an A, but this is not SSA. It's not SAS. Because in order to be SAS, the angle would have to be directly in between. If I had that angle, where I put that little dot, then it would be SAS. So right now, what I've got is this. Does that even look right? No. Don't write it down on a quiz or a test. It doesn't work. You'd be surprised because people will write this, which is just ass backwards. Don't write it down. It doesn't work. If I give somebody a side, and an angle, and somebody else a side, and an angle, and the angle is not in between, they won't necessarily generate the same triangle. This sometimes works, but we haven't done trigonometry yet. When you get to trigonometry next year or the year after, you will get the tools to test this and figure out, well, maybe they are congruent triangles. But this year we don't have that information, so we're going to write down that we have not enough info, or you can just write down not congruent. We don't have enough information to make a determination right now. Do you think you can remember that?
Yes.
Okay. Can you prove it?
Well, if you knew
trigonometry.
If you knew trigonometry, you might be able to prove it. And I'll show you an example afterwards to show why it doesn't work. Remind me after I get through with this one. What is that symbol?
Perpendicular.
Put it in. Put in 2 right angles. And we're going to treat midpoint the same way we treated bisect. Underline it and circle. something's getting cut in half. In this case, it's whatever I circled at the end, which is NP. Put a slash mark there and there. If it's getting cut in half, you got two equal pieces. Do we have a common side? Put it in. Now, focus on one triangle. What do you have? This is an SAS situation. R, N, O, congruent to triangle.
What?
Is that an O in the middle? RPO. Let me give you an example of why SSA wouldn't necessarily work. All right, let's make this side equal to this one. And let's make this angle equal to this one. And if we wanted SSA to work, the angle would not be in between the two sides. So we would choose this side and we would choose that one. So instead of the side being towards the angle, now the side is moving away from the angle. But it's still, this is still equal to this. This is still equal to this. This angle is still equal to this angle. But are they identical triangles? No. SSA doesn't necessarily work. Base could be short, could be long. But there are situations where SSA does work, but we can't prove that yet until we get some trigonometry under our belts. How many postulates or theorems did we just discuss?